Hello coders, I welcome you all. As you know, we have been working on our project, Water Potability Prediction using machine learning. In the last video, we performed data and code versioning. Now in this video, we are going to perform experiment tracking, which is very important in any machine learning project. If you are working on a machine learning project, you must know about experiment tracking. Let's first understand why we required experiment tracking in a machine learning project. As I said earlier, machine learning is all about experiments. At each and every stage of a machine learning project, we can perform some experiments, right? Let me show you our project code that we discussed in the first part of this project. Through this example, I want to explain the need of experiment tracking in a machine learning project. You can see that at the beginning of the project, we wrote the code inside a Jupyter notebook that you can see over here. Here we import various libraries that we require. This line loads the dataset into a pandas data frame. And as you can see here, we are checking for the missing values. You can see that missing values are present in pH, sulfate, and trihalomethanes columns that you can see over here. So now here we are splitting our dataset into two parts, one for training and one for testing that you can see over here. We will use the training set to train our machine learning model, and we will use test set to evaluate the performance of our machine learning model. So here we can say our test set contains unseen samples, right? And as you can see here, we are filling the missing values using the median of the respective columns, both for the training set and the test set that you can see over here. And here we have imported our classifier, random forest classifier, as well as this particular library, pickle. And here we are separating the independent and dependent variables of the training set for model training. And as you can see here, we are training our random forest classifier on the training set with n estimators set to 50 that you can see over here. And here we are saving our model using pickle that you can see over here. Now let's move on. As you can see here, we have separated the independent and dependent variables of the test set. And here we are importing various modules to calculate accuracy, precision, recall, and F1 score in order to assess the model's performance on the test data. And as you can see here, we are loading our saved model that we have saved over here. And here we are performing predictions on test data, means on unseen samples, and storing the predicted results in Y-pred. And here we are calculating accuracy, precision, recall, and F1 score using the actual values and predicted values from our model. This one, actual values and predicted values by our model. And here we are printing the results for accuracy, precision, recall, and F1 score that you can see over here. But here one important question is how we can determine if these are the best results. To determine if these are the best results, in machine learning, we need to perform various experiments, right? You can see that currently we have n estimators set to 50 that you can see over here. And we are using random forest classifier, right? By doing this, we are performing experiments because we don't yet know which values or algorithms will work best for this dataset, right? As I said, machine learning is all about experimentation. So let's consider this as our first experiment with value of n estimators is equal to 50. And we will change the value of n estimators for our second experiment. For teaching purposes, I have used only one parameter of random forest classifier, n estimators. But you can see, currently I am on scikit-learn.org website. There are many more parameters we can experiment with. As you can see in the scikit-learn, these many parameters are available. Means for these many parameters, we can perform experiments. But as I said, for teaching purposes, I have used only one parameter of the random forest classifier, n estimators. You can perform experiments with remaining parameters that you can see over here. Now let's perform our second experiment and let's change the value of n estimators to 100. Let's execute this cell, this and this as well. As you can see, we are getting different results. for accuracy, precision, recall, and F1 score that you can see over here. And here the results have improved as compared to the previous experiments, right? Now let's change it to 1000. Let's execute this cell, this and this as well. Again, we can see some improvements in the result because currently we have set an estimators to 1000. Now let's perform one more experiment. Let's change it to 500 and let's execute this cell, this and this as well. Again, you can see the results have improved as compared to the previous experiments. So, but here you can observe one big problem. If we perform such experiments repeatedly, we can only see the results of the current run. This one that you can see over here, meaning the results of the current experiment, the latest one, not the previous runs, right? There are many ways to store the results of the experiments. In a simple way, we can store the results of each experiment in a Google spreadsheet like this that you can see over here. But it's not a proper way to maintain it manually like this. There should be a techniques for experiment tracking. One such technique we are going to perform in this video is experiment tracking using DVC, data version control. In the future, we will use MLflow for experiment tracking. But in this video, we are going to discuss experiment tracking using DVC, data version control. But please remember, in this video, we are going to perform experiment tracking without pipeline, without DVC pipeline that we have created in the previous videos. In the next video, we will perform experiment tracking with our created pipeline for our project, water potability prediction using machine learning. But in this video, we are going to perform experiment tracking without pipeline using DVC. So let's get started. But before we move on to the practical part, let's first discuss what experiment tracking is. So as you can see, experiment tracking is the process of documenting and managing the information, processes, and outcomes of the experiments in machine learning. It involves recording various details about each experiment to ensure reproducibility, traceability, and accountability. You can see key components of experiment tracking: parameters, data, code, results, environment, and metadata. So during experiment tracking, we can record hyperparameters, configuration settings used in the experiment. Now data. During experiment tracking, we can also document the data sets used, including versions, pre-processing steps, and any transformations applied. Also, we can track the versions of the code base and the scripts used to run the experiments. Also, we can capture the outcomes of the experiments such as metrics, logs, and performance measures. Also, we can track and log the computational environment, including hardware, software, and dependencies used in our experiment. Also, we can store additional contextual information such as the purpose of the experiment, hypothesis, and notes. So these are the components of experiment tracking that you can see over here that we can track during our experiment. So there are various tools are available for experiment tracking like DVC, MLflow, weights and biases, and Neptune. So these tools are providing following features: logging, visualization, versioning, and collaboration. So these tools perform automatic logging of parameters, metrics, and artifacts. Also provides tools for visualizing experiment results and comparisons. They also support version control for datasets, code, and models. These tools also enabling team collaboration by sharing experiments and results. So finally, we can say that experiment tracking helps in understanding what works and what doesn't. Also optimizing model performance, ensuring reproducibility, and facilitating collaboration among teams. So now let's move to practical part. Now first let's open command prompt and let's move to D drive and let's create new folder x-dvc. You can give any. Let's move inside this folder and let's open VS Code from here using this particular command, code space dot. Now let's create two new folders. One with name data and second with name SRC. Now let's paste our dataset into the data folder. You can see our data set. Let me close this and let's click on SRC and let's create new Python file into this particular folder, SRC folder, with name water_model.py. You can give any other name as well. Now first we have to copy and paste this code from Jupyter Notebook to VS Code. Let me copy this. Let me paste it over here. So let me copy the code from Jupyter Notebook to VS Code. Let me paste it over here. Again, back to Jupyter Notebook. Let me copy this. Let me paste it over here. Again, let me copy this code and let me paste it over here. Let me save this file. So here, let me copy this path for our data set. So we have to replace this with this particular path and let's change this to double quotes. Now done. Let's run this code to check whether it is working properly or not. Let's open new terminal and let's run this code, which is available inside SRC folder with name water_model.py. You can see output from our code. Means we can say that our code is working properly. Let's clear this. And now our first step. So in the first step, we need to install DVC live using following command: pip install DVC live. Let's press enter. You can see in my case, requirements are already satisfied because I have already installed DVC live on my system, that you can see over here. Now the question is, what is DVC live? As you can see, DVC live is a Python library for logging machine learning metrics and other metadata in a simple file formats, which is fully compatible with DVC. Let's move down and you can see DVC live is an ML logger similar to MLflow, weights and biases, and Neptune, that you can see over here. So just remember, DVC live is an ML logger. By that, we can log in machine learning metrics and other metadata. Let's clear this. So now to track these N estimators and these metrics, accuracy, precision, recall, and F1 score, we need to modify the code. So for that, first we have to import from DVC live. Let's import live. So we want to track this metrics. So for that, we have to write with live and also let's set save_dvc_x to true as live colon. And we have to put the statements inside this with. And in place of this, we have to use live, this one, dot. You can see with DVC live, we can log artifact, image, metric, parameters, plot, etc. that you can see over here. But here at this point, we want to log metric. So we have to write like this. So again, here live dot log metric. Here as well, live dot log metric. And here as well, live dot log metric. So here we are logging this metrics: accuracy, precision, recall, and F1 score. Also, we want to log this parameter and estimators of random forest classifier. So here again live dot log param n underscore st meters comma n underscore st meters. So here we are going to log accuracy, precision, recall, F1 score and n estimators. Now done. Let's save this code. As you know, we are going to perform experiment tracking with DVC. DVC depends on Git. So that's why first we have to initialize Git. Then we have to initialize DVC. Here we have to initialize DVC because we are going to perform experiment tracking using DVC. Let's clear this. So please remember, here we are not using a pipeline. So for data versioning, we need to explicitly add the data using following command. DVC add data means in data folder, we have this file water underscore portability.csv. Let's press enter. Now done. Again, let's clear this. Now let's check Git status. You can see we have this many untracked files that you can see over here. So again, let's clear this. Let's add all to our staging area using this particular command. Git add dot. Dot means all. Now done. Now let's commit the changes. Git commit -m initial commit. Let's press enter. Now done. Again, let's clear this and let's run our code, which is available inside src with name water underscore model dot py. Look at here. Different files and folders are created by DVC. As you can see, dvc.yaml file has been created that you can see over here. As you can see, a new folder named DVC Live has been created containing plots, matrix.json and params.yaml that you can see over here, which containing metrics for current run that you can see over here. And params.yaml contains n estimators for this particular run. For this particular means for current run 500. So as you can see, currently we are maintaining n estimators inside this particular file, params.yaml file. So here we need to do one thing. We need to add code to fetch this particular value from this file to our Python file. So here we have to add this line. Before that, we have to import YAML and YAML dot save load, and we have to open this particular file, params dot YAML file. By default, it is in read mode, and from this file we have to fetch this parameter and underscore estimators. Let me copy and paste it over here. In place of this params.yaml, actually we have to take complete path for params.yaml. Let me copy this path and let's replace this with this path. Let's use double quotes. Let's save this file and let's assign it to one variable and estimators is equal to this statement. Let's save this file. And now you can see we are fetching value of n estimators from this particular file, params.yaml file. So this declaration is not required. Let's comment this out. Let's save this file. And here we have n underscore estimators that we are getting from this particular file, params.yaml file, this file. Now done. Let's clear this. Now you can see we have already performed our first experiment and you can see the result, and also you can see current value of n estimators. Now let's perform our second experiment and let's change this value to 100. Let's save this file And let's run this code. So here we are executing our second experiment. Now done. Let's clear this. So currently we have performed 2 experiments and we can check the results using this particular command DVC exp show. You can see here our 2 experiments, first and second one. You can see the experiments that we have performed, each with unique hash and assigned name by DVC and time created with accuracy, precision, recall and F1 score with a particular n estimator's value used. You can see 100 and 500. So you can see this way we can check results of our experiments that you can see over here using this particular command DVC exp show command. Now let's perform one more experiment and let's set n estimators to 200. Let's save this, let's clear this and let's execute our code. So you can see currently we are executing our third experiment with n estimators to 200. Let's clear this and again to check the experiment results we have to use following command DVC exp show. You can see 3 experiments and also you can see this is a TMP folder and you can see different runs, 3 runs for 3 experiments that you can see over here. Now let's perform one more experiment with n estimators to 1000. Let's save this, let's clear this and let's execute our code. So this is our 4th experiment that we are performing. You can see it is taking more time because we have set n estimators to 1000 that you can see over here. Now done. Let's clear this. Now let's check the experiment results. So as you know, to check experiment results, we have to use following command DVC exp show. You can see this is our 4th experiment with n estimators set to 1000 that you can see over here. So total here we have performed 4 experiments and you can see the results as well. So you can see this way we can perform any experiments as we want and DVC will log everything that you can see over here. And we can check the experiment results using following command that you can see over here. Now let's move on. As you can see here we have conducted these many experiments, but we want to compare the results of 2 experiments. To do this we have to use following command DVC exp diff for difference. Let's find difference with this and this. So here we are comparing this experiment and this experiment, 2 experiments. Let's press enter. You can see over here accuracy, F1 score, precision and recall with difference, with change that you can see over here. So this way we can compare different experiments that you can see over here using following command. Hope all of you are clear with this. So now let's move on. So as you can see, currently we can see all these results from the terminal. But what if we want to see these results in good looking GUI? So for that we have to install one extension. So you have to click here extensions and search for DVC, this one. And we have to install this particular extension. Let's click on install. You can see done. So if it is installed properly, you can see DVC logo over here. Let's click on this. So you can see different actions that we can perform using this extension, like show experiments, show plots, and run the particular experiment. Let's click on this, show experiments. You can see over here. It looks somewhat better than the terminal output that you can see over here. Now next, let's click on show plots. And here we have to add experiments that we want to compare visually. Let's add this and this. Let's press OK. You can see over here. So we can compare experiments graphically using this. So plots. So here we can add as many experiments as we want for comparison. It will display the comparisons in the form of graphs that you can see over here. Now let's move on. Let's clear this. Now suppose we want to remove an experiment from the list. Let's first display experiments that we have performed using DVC exp show command. Now suppose we want to remove this particular experiment. So for that we have to use following command: DVC exp remove and name of the particular experiment that we want to remove. I want to remove this particular experiment with n estimators 100. Let's press enter. You can see removed experiments with this particular name that you can see over here. Let's clear this and again let's check experiments. You can see here experiment with n estimators 200 is removed that you can see over here because we have used following command. So hope all of you are clear with this, how we can remove particular experiment from the list. Now let's move on. So before we move forward, let's perform one more experiment and let's set n estimators to 250. Let's save this file and let's execute our code. Now done. We have performed one more experiment. Let's check it using this particular command DVC exp show. You can see one more experiment has been added that you can see over here. So now here the important question is why we are doing these experiments. Please remember we are doing this experiment to find the best model that we can put in the production. So assume that we have performed this many experiments and we found one best experiment. So you can see in our case the best experiment is this particular experiment with n estimators is equal to 1000, right? So now we have finalized this as the best experiment, right? So here we want to use only this experiment. So we have to reproduce this particular experiment with n estimators is set to 1000. So we can do this with just one command. As you can see, current n estimators is set to 250. But we want this particular experiment, which is the best one. For that, we have to use this particular command to reproduce particular experiment that we want. DVC exp apply. We want to apply this particular experiment. So let's copy this name and let's paste it over here. Let's press enter. Before, please look at here. Now I am pressing enter. You can see over here n estimators now set to 1000 because just we have reproduced this particular experiment. So you can see matrix.json has been changed. Also params.yaml has been changed. And you can see that the entire code base and everything else have been updated according to the n estimators 1000 that you can see over here. And you can compare matrix.json with this value because we have reproduced this particular experiment. You can see both are same. So this way we can reproduce any experiment that you can see over here. Hope all of you are clear with this. So this particular experiment has given the best result. Let's commit this particular experiment. Let's clear this. Let's check Git status. You can see this many files are modified and untracked. So let's use this particular command git add dot to add these files in the staging area. And let's perform commit. Git commit -m paste experiment with and underscore estimators equal to 1000. Let's press enter. Now all done. You can see workspace has been changed as per n estimators 1000. So this way we can perform experiment tracking with DVC. Hope all of you are clear with this. how we can perform experiment tracking using DVC, data version control. In the next video, we will add this experiment tracking to our created project, to our created pipeline that we have created earlier using DVC. Hope all of you are clear with this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.